Hello and welcome to Learning Rust Programming series. My name is Ashish and today we are going to explore more about writing functions in Rust and memory management of the variables in the function. In Rust, functions are fundamental building block for organizing and structuring code. So in second video of this series, where we started with hello world program, we have seen you declare functions using this keyword function. Here is a simple function. I'm going to write function greet, which takes parameter named and type string. So this is a pointer to a string. And we are going to print this string inside this function. Let's call this function from our main method. So this is how you can write simple function in Rust. So this parameter is a reference to a string and which prints whatever we pass as a parameter. The function parameters are declared inside parentheses after a function name. And we need to specify type for each parameter. So suppose if I'm writing function as add and I have two parameters, one is x and second is y. I need to specify function parameter and we need to specify return type also, that is I32. So function parameter return type I'm going to specify like this, and inside this function we are going to write simply x plus y. We are not going to write semicolon. Let's call this function from our main method. I want to add 1 and let's say 5. So I need to print this value, whatever value is being written. So it's printing 6. So in this example, add takes two parameter I32, integer 32-bit, and it returns integer 32. In the Rust, return value of the function is synonymous with the value of final expression of the block of the body of a function. You can return early from function by using return keyword and specifying a value, but most functions return the last expression implicitly. So you can write return if you want to return somewhere in between from the function, but mostly you will see that most functions return from the last expression implicitly. So where you don't need to write a return statement, you don't need to add a semicolon also. So return values we write here after the arrow. Now let's understand the difference between expression and statement in Rust. Let me write one function multiplication. Sorry. Let's take example. So this is the function which is not returning. So this is a statement, whereas this is an expression. So I'm having A and B, and last. So this last statement is expression, which returns something, whereas this is statement which is executed. And let's call this function. This function, we don't expect anything in return. So yeah, so just wanted to show you the difference between exa statement and expression. So next up we have is Rust doesn't support. So next important thing that we need to understand is if you are from C++ or Java background, there is a concept called as function overloading. But in Rust, Rust doesn't support function overloading in traditional sense. Instead, you can use generics to write a function that work with a different types. So if you are aware of generics in C++, in Java, something similar we can have here also in Rust. So we pass generic type T and we set that type somewhere like this T, and then you can use that T here. All right. So here you can use value. All right. You can probably write println. And if you want to print type, then you can use standard function type name. and pass this t. Yeah, and what you can do is you can call this function print type and whatever value you want to. So let's say if I want to pass string, if I print this, then it will print. Oh, we have error. So it's printing and str. So let's understand what are lifetimes in the Rust. When working with the references like this, here we are seeing and str. This is and str. This is actually a reference. We encounter lifetimes whenever we deal with references. Lifetimes specify the scope for which references are valid. Okay, so let's understand through example what exactly are lifetimes. So longest, let's understand. Then you will need this port here. And then what I'm going to use is variable name, reference, single quote, then again this variable same. You have to use reference, then single quote, and then str. And for even return type, we will do the same. So whatever is the type, so A is the type, and yeah. So to use this, now we can use this both variables. S1 dot length is greater than S2 dot length, then return S1, else return S2. So what we can do is we can call these functions list print ln let's run this. Yeah, so it is printing John. If we use another string, the second parameter, it will print that. So this is how longest is taking two string to our references. So we'll be learning more about this in the next few videos. Just understand that these are string references with same lifetime and it returns a reference to a longer string. Now the next part is closures. The closure part, if you are coming from Java or Python, you would understand there's a concept of anonymous function or lambdas or even closure in languages like Python. Something similar we can achieve in Rust also. How to do that is very easy. We have to use let keyword. We use add one, and then we can use something like this. This is a parameter, and then how to use this is we can directly use like this. Add one and pass one variable. All right. So this is how simple you can use this uh, lambdas in anonymous functions uh, in Rust. So add one is the closure which takes parameter x, and we are adding one to that parameter, and here we are directly using that result, passing it to println. So by default, functions have private visibility. So if you want to make any function public, then you need to use pub keyword, and then you write public function keyword, and then you write public whatever function name you want to give, then like this. By default, it's private, but you can make it public by using public keyword. So yeah. So next we are going to discuss about memory allocation. In Rust, the memory allocation for variables, including function parameters and local variable, is determined by the ownership and borrowing system. Rust manages memory through a combination of stack and heap, and these decisions are made at compile time. Let's understand what is stack allocation. The function parameters and local variables and other data with known fixed size are typically allocated on the stack. Same as stored the languages. So whatever local variables are there, those will be stored on a stack. Uh, the stack is a region of a memory that follows last in first out model, and it's a fast and efficient for managing short-lived data. So very important, short-lived data is stored onto the stack. When function is called, its local variable and parameter are pushed onto the stack. When function exits, the stack space is freed. All right. So whenever function exits, then that stack frame is popped and memory is freed. So to give you example, if I have a function, let's keep it as it is, and I have two parameters here: x I32, y integer 32 bit, and we create one variable z equal to x plus y. Then in this case, what will happen? X, y, and z will be allocated on stack. All right, because these variables are local to this function. Now let's understand when heap allocation happens. For data with dynamic or unknown size, or data that needs to be persist beyond the scope of function call, heap allocation is used. Heap allocation involves requesting a specific amount of memory from the heap, and memory remains valid until explicitly deallocated. Rust manages heap allocation using box type for single ownership, and for complex structures like vector, VEC is the keyword for dynamic arrays. So let's take an example. So I will create both variables here in main method. So let's create string, which is, yeah. So this is the example of creating string on heap. Versus if I create a string like this, right? So this is the difference, and that's the difference between and str. And so and str, this is a pointer which points to a memory on heap, but this whole object string is allocated on heap. And if I want to use box keyword, then it will be used like this. If I create integer, then this is how I'm going to create box new and pass that value. So now even if I create new function here, and if I copy paste these two variables, then whenever this function is called, we have to understand that these two variables are going to get memory on heap. So let's understand ownership and borrowing. Rust's ownership system dictates how data is managed. Variables own their data, and ownership can be transferred between variables using moves. Borrowing allows functions to access data without taking ownership, and references can be passed around. So yeah, let's take one example. So here, if I have original string as it is, and then what I'm supposed to do is I need to create my own borrowed reference using this original string. So what I can do is now I can use this borrowed reference and use this clone method to create my own method. So I need to use here. All right. So in this example, original string owns the data, but the function borrows it, and the ownership is returned with clone method. Okay. So if this is the last statement, I need to remove this. So I need to return this string. Yeah. So in summary, Rust memory allocation strategy involves a combination of stack and heap allocation, determined by factors like data size, ownership, and borrowing. Stack allocation is fast and efficient for known size data with limited scope, while heap allocation is used for dynamic or long-lived data. The ownership system ensures memory safety, prevents issues like dangling pointers and data resist. So another example is vector that we have already used in our previous videos. And we'll be seeing it again in the next video, where we will be discussing about standard data structures available in the library. Like box is there, then vector is there, that we are going to discuss in next video. So if you have any suggestions around this video, you can comment on this video. The last part that we are going to see is how to write a test case using function. So we have Rust has a built-in test framework. So for that, you can write the test cases in the same file as your code, and they are executed with the cargo test command. So let's take an example. Suppose I have function. So we have function add. So I have add function x int I32, then y I32, and function completes here with x plus y, and I need to, now I'm going to use configuration test Then after that, going to use mod keyword. Then we are going to use and then what we are going to do is we have to write one test case, function test add assert equal. We need to, if it's not equal, then we need to let's call this function 2 3 and expected value is 5. Okay, so here we need to, in configuration, we need to use square brackets and yeah, exclamation mark. Okay, let's go to terminal and use cargo test command. Yeah, so it has run test case. Now if I, let's try to fail this test case. Yeah, you will see test case has been failed, right? So the answer should be 5. Yeah, expected test case executed as per expectation. So thanks for watching my video. Please share, like, subscribe if you are liking the content, and please comment if you have any suggestions or if you want me to make video on any particular topic in Rust. Thank you.